The silence. Sound is not a thing that travels on its own. It is a pattern of pressure moving through something. Air, water, steel, rock. Take away the something, and there is no pattern to carry. Space has almost nothing to carry it. Interstellar space holds roughly one atom in every cubic centimeter. A cubic centimeter of the air around you holds about 10 to the 19th. That is a 1 followed by 19 zeros. So an explosion out there makes no sound. Not a quiet sound. No sound. There is a careful exception, and it is worth stating properly. In places where gas is denser and hotter, pressure waves do travel. Astronomers have traced ripples through the gas filling the Perseus galaxy cluster, spreading out from the center. If you work out the pitch, it is far below anything a human ear could hear, by a very large margin. So the honest version is not that space cannot carry sound. It is that almost everywhere there is not enough of anything for sound to move through, and where there is, the notes are impossibly deep and impossibly slow. Old light. Sunlight takes about 8 minutes and 20 seconds to reach us. That part is easy, and it is exact, the distance divided by the speed of light. The interesting number is what happened before that. Energy is released in the core of the sun, where hydrogen fuses into helium. To get out, that energy has to cross the body of the sun, and the interior is not transparent. A packet of energy is absorbed and re-emitted constantly, in a random direction each time. It does not travel outward. It staggers. A random walk covers ground very slowly. The result is that energy released in the core takes an extraordinarily long time to reach the surface. Here I have to be careful, because this is a number you will see stated confidently and differently in different places. Estimates range from about 10,000 years to a few 100,000, depending on the assumptions used about density and opacity. The often quoted 100,000 is in that range, but it is not a measured value. What is not in doubt is the shape of it. The light falling on your hands outside took 8 minutes to cross the gap, and something like the age of human civilization to get out of the sun. The first measurement of light. For most of history, light was assumed to arrive instantly. Ole Romer was working at the Paris Observatory, timing the eclipses of Io, the innermost large moon of Jupiter. Io passes into Jupiter's shadow on a very regular schedule, a little under every 2 days, and it was being used as a clock. The clock did not keep time. When Earth was moving away from Jupiter, the eclipses ran late. When Earth was moving towards it, they ran early. Over the course of a year, the timings drifted by around 22 minutes and then came back. Romer's explanation was that nothing was wrong with Io. The light simply had further to travel when the planets were further apart, and it took time to cross the extra distance. That is the first real evidence that light has a finite speed. He did not publish a value in modern units. Christian Huygens took the timing and the best available estimate of the size of Earth's orbit and worked out a figure. It came out low, mostly because the size of the orbit was not yet well known, but it was the right order of magnitude. The method was sound. The measuring stick was not yet accurate. That is a very common shape in the history of measurement.